Okay, so yeah, feel free to start your presentation. Thank you.
Yeah, okay, thanks again for having me, Dominic and Jim. So I'm Wendelin Reich, Wendy, for my friends and everybody else. I'm the CEO and the CTO of Virtual Beings. We're a startup that's based in Paris, France, as well as Delaware. So technically we are a US-based startup, but all our operations are in France. I myself am German. And we have a small team here in France that's been developing tech for a number of years to make AI characters come alive. That's our thing. So we have already seen several years ago this massive demand among players to have NPCs that are more engaging. Like we always feel the pain and the disappointment of players who interact with games in beautiful worlds with amazing gameplay, and the AI characters continue to feel like robots. And that's the problem we're solving. So we've in a backstory, which is a little bit woven into this presentation, but I want to emphasize from the beginning that this is not in any way a sales pitch. I have a lot of knowledge to share, and I want more people, including more companies, more startups, to just enter this whole space of making better AI characters. And today specifically, I'm going to talk about combining our main thing, behavioral AI, with conversational AI, which has, of course, become like the en vogue thing over the last year. So let's get started. So as a reminder, why do we do this? We do this because great AI characters are a sci-fi dream, right? They're everywhere in popular culture. You don't even have to look. You just find in movies like blockbuster hits like Ready Player One and Blade Runner 2049, you always see virtual characters, and they're always portrayed as highly desirable, and they are portrayed as believable. And of course, AI characters are already a thing in games today. More than 50% of games feature them in some form or another. And if you're in XR, then it's actually closer to 60%. For example, if you look at the top 25 games on the Oculus Store, right? It's 15 out of 25. Now, the problem is, like I just mentioned, and yeah, I'm going to show some evidence that players are not impressed. They feel that AI characters today feel uncanny and scripted and robotic. So everybody has seen lots of memes on buggy NPCs, but have a look at what this actually means, especially here on the right. So this is from a $6 billion game, Pokemon Go. This is one of the star mobile IPs in the world, from a company that certainly has the resources to put love into AI characters. And yet still, when you are in AR mode with your little monsters and you nourish them, they don't even look at you. They don't even pretend to ingest food. It's all like crappily done. And I hope it's okay if I'm punching up here. I love Niantic, but this is kind of obviously lacking, right? And you can look on YouTube or on Reddit. There's lots of fail reels, videos about bad NPCs get tens of millions of views. Sometimes it's the thing everybody talks about, like with Cyberpunk 2077 here on the left, right? And it's just a systematic problem. Now, there's already startups trying to change that. There's a new generation of AI character startups, like In-World, like Convey, like Carter, and several others, which have raised a lot of money over the last 2 years or so. And here you see the kind of promise. This is from a demo by NVIDIA. It actually only shows one thing, just conversational AI. And that's something that all of you know very well, because I assume all of you use ChatGPT by now, as everybody does. You just instruct ChatGPT to pretend to be a person, and it will have a believable dialogue with you, with GPT-4. So conversational AI is kind of a solved problem. And what NVIDIA didn't really talk about loudly is that the rest of this demo is just like the usual game developer bells and whistles and eye candy, right? A realistically moved camera, beautiful physically based rendering, but the character is just in an animated loop. Voila, there's no AI to speak of, right? It's just conversation. I mean, there's no AI besides the conversation AI. So if you look at how this is being deployed in games today by some startups, then there's this real difference between the dream, how we all wish AI characters converse, and how they actually converse. Again, this is something that you can check out yourself easily via YouTube or so. And professional game developers have commented like these kinds of value propositions about basically conversational NPCs loudly on LinkedIn and on Twitter. They are not impressed. This is not something game developers see as deployable into games today. Basically, a chatbot that stands in front of you and talks a lot and is powered by a GPT-4. So this is where we come in. At Vertibeans, we are the original inventors of behavioral AI. And behavioral AI is about making characters that feel alive. This is captured directly on a Quest 2 headset. And to prove to you that I'm not bullshitting you, I would like to switch to a quick live demo to just give you a clear sense of what behavioral AI means. So let me reshare my screen. And by the way, Dominic or Jim, can you confirm whether the frame rate is good?
I think so far the frame rate is fine. I didn't see any poor connections on LinkedIn Live, so feel free to do it and let's see how it goes.
Yeah.
Yeah, as long as everyone turns off their video, we should be okay.
So let me switch to casting here. Okay, and I'm going to have to do this one-handed. Okay, so I'm here in a room with our demo bird, Tropical. And you can see like he's perching on my finger. All this is procedural. All this is interactive. He follows my look, right? He really enjoys being touched here. Oh yeah, that's very nice. There on the head, on the belly. Let's see what happens if I touch him on the tail. Oh, did not like that. And here I decide when to let him go. He has to adapt procedurally. And let me also feed him a bit. Little one. Yes. How about I touch you some more? Yeah. Okay, that's a good boy. Here we go. I think that's enough.
Cool. So like this one is totally like when you open it and there will be a bird and you can interact it, right?
Sorry, I had to take off the headphone for a second there. Can you repeat your question?
Oh, yeah, sure. So is that an app right now on Quest Store that people can download? What's the name of it? And yeah, it's called Cute Engine. What's the name of this app? And people can download and try it. Yeah.
Yeah, there's two things here. There's an engine That's our AI engine, which is based on 12 years of R&D. It solves a lot of the hard problems in behavioral AI, procedure animation, virtual cognition, and so on. And there's an app, and the app is coming up soon, in a week or two. I'll keep you posted on Oculus App Lab, and it's called Space Companion. So it's not going to be this room. It's basically a tabletop simulator and, sorry, a tabletop board gaming simulator where you get to interact with not just one character, but two. And I'll talk a little bit more about that later when I show you some demos that are related to the topic of this talk. So I'll come back to your question there. Just to mention that behavioral AI is not just about birds, right? It's about all sorts of characters. And it's always about giving the player the impression that the creatures they're interacting with are real, that they are alive. So it's the illusion of life, to quote Disney here. It's the illusion of interactive life, which you're going for when you're serious about behavioral AI. So I want to briefly mention what goes into making behavioral AI. The first component is virtual cognition. Virtual cognition is about giving your characters the ability to perceive and understand the world they're living in. So seeing objects, seeing space, understanding what part of space is navigable, and to always do that dynamically. So we have built this tech into our engine to make it 100% dynamic, which means there's no assumption about where objects are at editor time, right? The game world can change, the player can change the game world. Our engine doesn't care. But it still works if you use standard Unity or Unreal navigation, for example. You can still do behavioral AI, but it's just not going to be as dynamic. The second component is procedural animation. Like you just saw in the live demo, in order to create the impression of believability, you need to have an animation system that adapts to the needs at runtime. For example, if I move my finger, then the bird is able to adapt. Of course, that cannot be done with canned animation. That has to be procedural. And finally, in between the two, you have the problem of behavior synthesis, which you can think about in this way. So let's say you, Dominic, are walking along the street. You're walking, maybe you're looking at your watch, and now you see a friend on the other side of the street, and you're waving at them. Now, did you have to stop walking in order to greet your friends? Of course not, right? It's normal to do more than one thing at a time. That's what bodies are made for. And sometimes there's a lot of things going on. When our bird character perches, there's roughly 15 things happening at the same time. So it can be quite complex. You need to have a system that puts those 15 components, so to speak, together. So you get one single continuous animation stream. And you don't have to stop walking when you're greeting someone, right? We also talk a little bit on our blog, on the Virtue Beings blog, about what kind of design principles you want to think about if you try to believe this kind of tech yourself, which I hope many of you will do in the future. We talk about the 12 principles of behavior. Again, that's an homage to Disney and his 12 principles of animation. And it's a little bit complicated, so here I just want to highlight a few. We have discovered over time that all behavior is interactive. It adapts to the needs of the situation. It's sequenced, meaning that you often have parts of behavior that kind of feel scripted. Like, for example, dancing is actually a very scripted activity, but it's still interactive. One doesn't exclude the other. Behavior is always interruptible. So if you do something and something else happens that forces you to change direction of behavior, you're always able to do that. Your animation system as a human being or as a cat doesn't break down. And there's a few more. And you can find all of them on our LinkedIn if you find this interesting. The most important principle, though, is to always start by analyzing real behavior. That's like the number one lesson I want anyone to remember about behavior AI. Just with good animation, always be inspired by the real world. Right here, you see a raw animation that is then procedurally adapted, which was created by our lead animator in order to convince you that our little bird character is sneezing, right? And this was inspired by actual sneezing. Before that, I didn't know that birds can sneeze. It turns out they do. So always analyze real behavior.
Yeah,
No.
and there's a person kind of like our audience has a question. He asks, is the AI running in the headset or are animations driven from a remote server? What are implementation for multiplayer seeing the same animation at the same time? More technical question.
Yeah, this is a great question. And it's so great and so important that we'll end up talking about this a lot, because it kind of differentiates conversation AI and behavior AI. I think when you see these GIFs, which were all captured on device live on either headsets, Quest headsets, or mobile devices, you can see that reactivity is very fast. Like whenever you talk to the cloud, you are going to introduce lag because you have to talk to the cloud and the cloud has to talk back to you. Now, this is not really possible when you interact with the body of a virtual character. It has to be fast. So all our behavior AI runs on device. And that's why we had to build an engine for this, Qt engine, which you can read more about on our blog. But even if you just go with good old behavior trees, you want to do this yourself, and you want to use standard tools like Unity's navigation system, that is still going to run on device, right? Like old school game AI that runs on behavior trees is still going to run on device. And there's no alternative. You cannot have a laggy character when you're like talking about animation. Does that answer the question?
Yes, and I mean the large language model, like how can you conquer that the speed and all those like aspect, engineer aspect? Because if you want to build,
we'll get to that.
Yeah, okay.
This is such a cool question that we'll get to that now.
Yeah,
very quickly, in fact. So let's first zoom out a little bit, watch a bit of Friends together, and like talk a little bit about the connection between conversation and behavior. So here's an old scene meeting her dad, as I called it. You see Ross from Friends, you see his girlfriend Liz, and you see Liz's dad, Bruce Willis. Let's analyze this in detail from the top. Okay, so Liz says, this is my father, Paul Stevens. Dad, this is Ross Keller. Ross says, it's great to meet you, Paul. And Paul says, I usually prefer Liz's boyfriends who address me as Mr. Stevens. So he plays the stern dad. Let's look at it slowed down here. Okay, 50% slowed down. When Liz introduces her boyfriend, she makes a gesture. She reaches out towards her dad. When Ross greets her dad, he takes a step forward. What does that signal? It signals deference, right? You know that intuitively. That's a way of showing respect towards the dad of your girlfriend. Whereas Bruce Willis, the dad, stays here in place. He waits for his potential future son-in-law to approach him, then locks his hand and Trump style gives him a little humiliating speech while he shakes his hand. So there's a lot happening, both in terms of conversation and in terms of behavior at the same time. The two are deeply connected, they're interlaced. And that's normal, right? That's not special. I took some random episode of Friends here. You could film yourself, right? We constantly mesh behavior and conversation in our daily lives. And if the two are disconnected, or if one of the two is missing, we feel that we're looking at something uncanny, which is the problem of some of the previous demos I showed earlier about NVIDIA, for example, that does conversational AI, but not behavior. Now, to actually start talking about the problem that was just mentioned from the audience. So conversational and behavior AI require different tech stacks. I already told you a little bit about behavior AI, the 3 problems that you are going to have to solve. Let's start with conversational AI, therefore. So conversational AI, if you want to do it well today, you are going to have to use a large language model. Large language models are pre-trained. They are large for a reason. You cannot train them yourself unless you're very, very rich and very, very good. And because of their size and their complexity, they're served via the cloud. There's no real exception to that unless your models in reality are not very large. So anything more than, let's say, 7 billion parameters or so, you're not going to be able to run on any type of PC that you can buy in a store, right? You're going to have to build something like a server. So it's served by the cloud, and it's adapted to your needs as a developer by a pretty standard process. There's always 3 steps nowadays, and you may skip one of them, but like if you want to do the whole shenanigans, then you're going to do fine-tuning. Fine-tuning means that you continue the pre-training process yourself with a small amount of data on a cloud server, maybe like Google Colab or something. And you're going to do it quickly using a reduced data set in order to make the model understand your type of problem. So for example, we fine-tune our we fine-tune pre-trained models to make them understand what kinds of responses are typical in our games, right? And that's what everybody else does, right? It's not a mystery. Then there's RAG. RAG stands for Retrieval Augmented Generation, and it basically allows the large language model to rapidly talk to a database, and you want to do that in order to give it access to context. So you all know that ChatGPT or Claude, they have a knowledge cutoff. It was recently updated, but there's still a knowledge cutoff. ChatGPT does not know about the current war in Israel, right? It just doesn't. However, you could make it answer questions about that war if you use RAG and use a database that is filled with very recent newspaper articles, for example. And finally, there's prompt engineering. All of you have done that if you have ever talked to ChatGPT. It just means providing textual instructions that are prepended to any queries that you make to a large language model in order to tell it what kind of output you want to do. And this can become very sophisticated. So the word engineering is quite meaningful there. It can be a lot more complex than what you would normally do at home. Now, behavior AI, on the other hand, there's not like one standard solution which everybody uses. It's actually a myriad of specialized algorithms. You need to solve so many different problems: navigation, steering, animation, behavior synthesis, virtual cognition, distractibility, attention, personality, emotion. I could go on for half an hour. There's a lot in there. Behavior is just messy because brains and organisms are messy. Like I mentioned before, it always has to run in real time in order to be satisfying to the user. And when I say real time, I mean like super duper real time. So Qt Engine, for example, our take responds always on a per frame basis. A Quest 2 runs at 72 Hertz, which means that you have a budget of a 72th of a second on a tiny mobile chip that's in your Quest 2 or Quest 3 in order to get your computations done. Not a lot of complexity there. However, you can still use language models. They're just going to be not super large, so kind of small large language models. It depends on your problem, how performance sensitive this is, but you're not going to run a 7 billion parameter model. You're going to run something below 1 billion parameters, and if you want it to be fast, then more like 100 million parameters or so. Now, recently, a guy called Swix, who was very influential in the San Francisco generative AI scene, has called out this distinction between LLM as the core and code as the core of your architecture. And it maps quite nicely to what I just talked about. So if you have an LLM core system, that would be a little bit like you using GPT-4 today, especially if you use something like Code Interpreter or DALL-E 3 to generate images, right? The LLM is the app. You're talking to the app, and the app, the LLM, decides autonomously, of course following rules, but autonomously, whether it should branch out and query other services, whether it should use tools. And it's already pretty good at that in the case of GPT-4, right? And other companies are following suit. The point is the LLM is at the core. You could also build a system that is the opposite, that has code at the core, which is something every game developer understands very well. You have like your typical game architecture, for example, and then you branch out when you need it and query LLMs. I hope the distinction is super clear, because it's about who's in charge. Your code, hand-authored, or the LLM, which is not hand-authored, which is pre-trained. And conversational AI is typically carried out by all AI character startups that I know about, like InWorld, Carter, and so on, that do conversational AI for characters. The LLM is the core, whereas behavioral AI, you would have to put the code into the core because of the performance requirements. Now, how do you choose between those two architectures? And I think about it this way, like, what do you want to build? Do you want to build an autonomous agent like ChatGPT, or do you want to make a game? And if you want to make an autonomous agent, or you want to build AGI, power to you. That's great. It's not my problem. I wish you good luck, my friend. I'm from game development, and I want to create systems that are fun, that are monetizable, that are scalable, that are distributable. And those systems are kind of well known because we've been building games for like 50 years now. So this is really pretty crucial when you think about games. You want games to be controllable, and that's a total no-brainer if you think about it. If you use NPCs, then NPCs have, for example, be able to give the player a quest, and that has to happen at the right moment during the gameplay. Right? Think of like the last time you played The Witcher or The Last of Us 2 or so. NPCs are there for a reason. They are tied into gameplay. Secondly, the LLM core model is very costly because each query to the cloud, to a very large language model, incurs compute costs. And then thirdly, as already mentioned before, there's the problem of latency. And games tend to be fast. You want things to happen quickly and not within like 1 to 5 seconds of latency. I used to joke, like, having an LLM core architecture, like, or having an autonomous agent today is like having a Zoom call. So a little bit what we're doing right now, right? It is interactive, but it's not super duper interactive. Like, it's not the same as being there with someone, like seeing me looking into my eyes and being able to raise your hand or so. And I've never met anyone who wants to have a Zoom call with an NPC. If you find one, then let me know. That would be a very unusual type of gamer, in my view. Yeah, and by the way, if there's any questions about this whole approach, then please let me know. I can just break it up. In the meantime, if you now decide, like me, that you want to develop games and you need to develop a code core architecture, congrats, you now have 4 new problems. And I want to break them down and show you some examples about how they can be solved and how we at Reality Beings solve them. First problem is, okay, you have a game. How can this game understand the player if the player uses conversation? Right? Because conversation is free. You cannot force the player to say this or that kind of sentence. Conversation is a lot more complicated than pressing buttons on controller. Second problem, how can we respond to the player via conversation, but also via behavior? Third problem, and that's a separate one, how can we take the initiative in conversation? How can we say things at moments when there's no currently ongoing conversation? That's not a problem that, as far as I know, any conversational AI character startup is even thinking about. And I don't quite understand why, because it's such an obvious one. And finally, the fourth problem is also the most important one. How does your support for conversation tie into the game design? How does it support the game design rather than counteracting it? Let's look at these one by one. So firstly, the problem of understanding the player. Understanding the player, like I mentioned before, means understanding a very, very unpredictable entity, a human being, who can use language in any way they wish. And this is only doable via machine learning today. There's just no second game in town. That doesn't mean it has to be in the cloud, though. There's ways to make just the understanding part actually work on device. If you're interested in details here, I'll gladly walk you through the details. So the first thing you need is you need to have an idea what it is you're trying to understand from the player. And we at Virtual Beings, some of our founders, we come originally from behavioral science and linguistics. And so we know that there's such a thing as speech act theory, which is an old theory from linguistics, which is super useful in this context, which says that basically whenever people say things, they also do things. For example, when I say, hi, Dominic, what I do is I greet you. And that is not just a conversation, it's an action. And if I understand, or let's say if you, Dominic, understand that I'm greeting you, like that I have taken the action of greeting you, you already know what to do. For example, you can greet me back. You don't need to know the details anymore. You don't need to know how I greeted you, what language I used, exactly what words. You just know that you are expected to respond with a greeting. And that's super useful. And it turns out that that is a problem that you can solve with natural language processing very well today. And you can solve it on device. It's a little bit cutting edge, though. Quickly, to let you know the tech setup we use at Virtual Beings, feel free to ask me questions later or after this. I'll leave my contact info if you're interested in the details here. So first of all, we use Unity Sentis, which is currently in beta. It's Unity's solution to solve machine learning models on device, to do so-called inference on machine learning models. We also use a library called Sharp Transformers by Hugging Face, and we use models in the BERT family, BERTs developed by Google, which allow you to do many different types of tasks on natural language processing. And here, like the task is to detect speech acts behind utterances. So how does this look like? Let's see if we can share audio. Dominic, please let me know if you have audio here.
Very like, yeah, not really having it. Can you kind of?
Yeah, it isn't coming through.
Yeah, it didn't
It
coming through. Yeah, I was trying to
okay.
figure out the bird.
Yeah. Okay, I can increase the volume. I'm prepared for this. Like, I didn't expect the audio to also work across the Atlantic using PowerPoint and Zoom and LinkedIn. That's maybe asking too much. So we have captions there, and I'll tell you what's happening. Here, the player is asking, hi, little bird, and the bird understood that she's being addressed here and responded. Right, and there's she's actually off and looking for a gift for the player. By the way, this is captured from our upcoming game. It's called Space Companions, which is going to be out in a couple of weeks or so as a beta on App Lab. I hope as many of you as possible can check it out and let us know whether you like it. Now, I also want to contrast this. Let's say the player says the same thing, but he says it in a different, they say it in a different context. So we've we're able to support this problem using the kind of machine understanding, speech understanding that I mentioned before, and also understanding context, because we are, after all, the developers of the game. Here, the player is, let's go again from the top, addressing Gary the robot in a way which Gary finds strange, and he responds accordingly. So the same sentence uttered at a different creature in a different context has a different effect, which is crucial. Let's go to the second problem, the problem of responding to the player. I mentioned that before. So this is a little bit different. It is doable both in the cloud or outside the cloud, but it will have different consequences. So responding to the player means generating a response, usually textual response, which is then translated into via text-to-speech and lip sync into something that a character says. And you want this response to be interesting, right? You want it to fulfill a function in the game, to make the player happy. So if the goal of the game is to be a complicated conversational partner, let's say you're meeting a virtual Sigmund Freud or a virtual, I don't know, Rihanna or so on, you're having a conversation, then this is probably going to have to use a large language model, which means you're going to have to use the cloud. Like you're still going to start with the problem of understanding the player as before, but then you're going to talk to some backend that you probably created yourself, so you control it, which can still use standard tools like ChatGPT, get a response back, and accept that you have to have a loop of waiting between 1 second and 3 seconds. It really depends on like where the player is and what kind of services you're paying for. But you're not going to get it really below 1 second. And we usually don't get it below 2 seconds because we don't have our own servers. If you want to do super duper cutting edge stuff, then you can probably figure out a way to generate interesting responses on device. We are working on that. Like if you find this problem interesting, please ping me. It means using small models and heavily fine-tuning them so they make sense. Because small models are a bit dumber, so you have to over fine-tune them so they make sense in the game. Yeah, it's pretty standard how you would use this with a cloud-based approach. You would use like one of the standard APIs, like OpenAI APIs. That's the standard right now. You would choose a standard model like Llama 2 or Mistral. For the fine-tuning part, if you want to fine-tune your model, then you would probably generate data, because GPT-4 is very, very good at generating data, which you then use to fine-tune smaller large language models. And you would use one of the typical backend serving platforms like Modal or Anyscale or AWS to serve them. Now let's look at how this works. We use Modal, by the way, and we use a fine-tuned version of Llama 2, which is probably going to change very soon. So player says, hi there. Gary responds after talking to the crowd. Hello, how are you? Want to play a game? Here, Gary not only responded correctly, but he also, since he controls the chess table, like initiated the chess game. So you see again the meshing of conversation and behavior, right? What you said to Gary had an impact on the gameplay. Let's look at another example. Player says you're a quick learner. Thank you, I try my best. Your move. Okay. All right, let me think. And in order to make his response interesting to the player, he actually enacts the thinking part, right? So he combines, again, conversation with behavior. Let's go to the third problem, the problem of taking the initiative to talk. This is actually something that games have done forever. The most simple way of taking the initiative to talk in games are called barks. It's when you, let's say you play Far Cry, whatever version, let's say 4, and you're raiding a camp and you're starting to shoot around with your rifle, and you hear some NPC in the background calling attention, or he's there, or something like that, right? That's a bark, and it's a derisive term because barks are really context-free. They're completely scripted conversational events, and players know that, right? You always feel like, oh, this is just a game, being gamey, being scripted, being designed, and trying to convince me that there's real life in there, which I know it isn't. You can also become a little more sophisticated and let the player trigger conversations themselves, for example, by letting the player become close. You use a proximity trigger. You can let some more abstract gameplay, for example, progression, decide whether some kind of godlike narrator takes the initiative to say something. You find that in a lot of 2D platformers, for example, let's say Ori and the Blind Forest, where you go through a door and then suddenly you see a dialogue appear. And finally, of course, scripted dialogue sequences, sometimes with dialogue trees so you can respond. Now, no one ever told me that they find this kind of dialogue initiative taking believable. It's just too far removed from reality. So I think in the spirit of what I said earlier about always being inspired by reality, you have to ask yourself, what makes real people take the initiative to talk? And for that, you need, again, a theory. And not surprising by now, it's the same theory again, speech act theory. It turns out that in real life, there is only one reason why people talk. Humans talk in order to influence. This is really crucial. It's a fundamental axiom. Let's say it in evolutionary linguistics. Conversation is not about sharing knowledge. That can be an indirect effect. It's about influencing someone. And you can influence someone by sharing knowledge, but sometimes you influence them by giving them an order or asking a question or by manipulating them. Influence is always the key. And the good thing about this theoretical approach is that it, again, allows you to use the same kind of theory that you already know by now, which is speech act theory. Speech acts are the kinds of acts that people use in order to influence their audience. A greeting can influence a listener to greet back. A question can influence a listener to give an answer. An order can influence a listener to comply or to not comply, and so on. Right? There's many dozens of types of speech acts, and if you Google it, you can figure it out yourself. So we at Virtue Beings, we use parametric speech acts to initiate talk and influence the player. And we do that because this puts gameplay first, which is always necessary, but it doesn't repeat the errors that I mentioned about traditional game dev, which is that dialogue that was initiated by the game feels very scripted and stiff. So it allows for very varied and talk that feels unscripted to the player using parametric speech acts. And you can do this without machine learning, but that's going to limit how creative you can be. And you can also use machine learning on device for the purpose of natural language generation, NLG, another thing worth Googling. So again, let's look at a few examples. Gary the robot again, playing chess with you. Here, player just made a move, and in response to something that happened on the chessboard, Gary takes the initiative to speak. And here, I think it was a scripted response, but we might as well have branched out into a backend in order to generate the response. So here, another situation. Gary sees Sunny, the bird, and invites Sunny to perch on his finger by talking to him. So gameplay gameplay sensitive conversation that's integrated to behavior. Finally, I've mentioned that the most important problem is always to be tied to game design, to serve the game designer. Because in games, I firmly believe that it's the game designers who are the kingmakers or queenmakers. If you look at a game like Candy Crush, which has just killed it for 12 years or something, it's not so popular because of the beautiful graphics or whatever. It's the game design, the meta game, and all the art and science that has gone into this. Game designers are the black wizards of our industry. So we want to empower them. We don't want the AI to take control away from them, which means that AI characters need to be controllable. And for that to work, our simple but functional approach is to just distinguish between types of behavior, which includes conversation, and how they integrate to gameplay. First of all, there's gameplay integrated behavior. So that, let's say, behavior and conversation that is really deeply tied to the gameplay. Example from before was giving the player a quest. This is something that you most definitely always want to script. There's no good reason to not script it, because you want this to be predictable. You want this to be the same type of experience for every player out there. It doesn't have to feel fresh and unscripted, because it ties into the game itself, right? It allows the player to do new things. There's also what I would call gameplay adjacent behavior. So that could be anything that the NPC, your AI character, does that is related to gameplay, but not in a strong way. For example, a small scene in The Witcher where you enter a bar and you have a little interaction with the barman. This is tied to gameplay, but it's low stakes. So it's gameplay adjacent. And finally, gameplay orthogonal behavior and conversation, which is when, for the case of conversation, you are interacting with an NPC, and this NPC is telling you about their backstory, and you're just interested in the backstory of the game. It's super low stakes. It has no gameplay impact, right? You learn something about that character, but it doesn't allow you to progress in any way in this example. And in that sense, it's gameplay orthogonal. Now, the further you go down in this list, the more you should be inclined to use real conversational AI, using definitely LLMs and possibly the cloud, if that makes sense in your cost structure, in your tech setup, because the conversation becomes more interesting, it becomes more varied, and it's further removed from gameplay, so it's low stakes. It basically defines the level of control. And as a lesson here, keep in mind that sometimes scriptedness is a feature, not a bug. So gameplay integrated needs to be scripted, gameplay adjacent needs to be somewhat scripted, gameplay orthogonal can be unscripted if that works for you.
There's an audience has a question. He asks which books are good for understanding in deep speech act theory.
Great question. I didn't mention that here. There's really only one book, and it's called, surprise, surprise, Speech Acts. It's called. It's written by John Langshaw Austin. I think it published in 1960 or so. It's really old, from the academic field of linguistics, and it's still, I would say, it's the best book. There's also like a more cited book by John Searle, also called Speech Acts. No, sorry, actually, John Langshaw Austin's book is not called Speech Acts. He talks about speech acts, but the book is called How to Do Things with Words. So that's what you want to Google, how to do things with words. Searle's book is called Speech Acts, but it's very academic and very abstract, and in our mind does not readily lend itself to implementation in a game system. whereas Austin's older approach was a perfect match.
What's the second book? I got the Speech X, and what's the second one?
Okay, that's J.L. Austin, like this city in the state of Texas, Austin. How to do things with words.
To do things with words. Okay, so yeah, I will kind of share those books with the audience. Yeah, because a lot of people are very interested, and I find out today's topic is very intriguing because, yeah, we are looking for a sentence, Unity sentence, for more like an automation, the kind of like a XR games, MetaHuman. But I think your way makes sense because we want everything curated, and we don't want like every conversation run large language model. It's not efficient. So I think your way makes sense. It's kind of a little bit, but very curated. Yeah, but yeah, please go ahead. I will copy and paste those answers. Yeah.
Like it's really about finding the right compromise at the moment. Unity Centers is already a crucial role. It's amazing technology. We use it. We love it. But it's limited by the performance of your device. And whenever you do XR, you need to remind yourself that you're basically putting a smartphone onto people's faces. So the performance is what it is. Now, takeaways to wrap up. Hopefully there's a few more, but here are the ones that I find most important. First of all, always decide what you are trying to build here. Like, are you building an agent? Which I see a lot of game developers which have playing around with GPT-4 in recent months do. They're kind of more intrigued by testing out, like, how far can I go with GPT-4? That's cool. It's probably not going to scale. You're not going to be able to afford the cloud costs. You're not going to make your players really happy. But it's a nice experiment. If on the other end, you're making a game, this is going to have a lot of downstream consequences. Most importantly, and that's the second takeaway, that you're going to have to prioritize control, cost, and latency, and you're going to have to opt for a code core shell model. So you can use LMs, but selectively. They'll never be in the driver's seat. They'll always be like tools that you use. Third, I can't emphasize this enough. If you think about what kind of conversations you want to design with your conversation AI, keep in mind that conversation is a part of behavior. I've spent some time today talking about that, so I hope this got through. Conversation is a part of behavior, and behavior in a game is part of game design. And sometimes the best thing to do is to have no behavior, or to have no NPC, or to have less AI or something, or to have more scripting, because it can be more satisfying. We always go for a mixture, I would say, in our product, or when we work with clients, because we're mostly a B2B company, because we just put game design in the driver's seat. And finally, and this is probably the least satisfying part of this talk, building behavior AI, even more so than conversational AI, is a marathon. It's not a sprint. It's very hard. We've done it for 12 years. It's also very rewarding. And we feel like when players take off the headset and they have just interacted with one of our characters, and they tell us, I just interacted with a living bird or with a believable robot, and not I just interacted with an NPC. That's what we're going for, right? That's what makes us proud. But getting there has taken many years, and this is still a small field. Conversational AI is also still early, so just try to think long-term here in your development and your investment strategy. Yeah, and if you found this interesting, please join our hub, our Value Beings hub, where we talk both about our products, but also have open conversations about everything you learned about today. We always love to learn from developers out there, or just enthusiasts. And with these words, I would like to thank you for your attention. Please find me on Twitter or LinkedIn. I'm very Googleable, so just put my name in the search box. And if you have any questions about AI in games, whether it's conversational or behavioral, just use this link for a meeting with here. It's free. Like, I will not sell you anything. I'm very curious to learn how people use this kind of tech in games now. We feel this is going to be the next frontier in gaming. And I just love to have these kinds of conversations. So thank you. Thanks for having me.
Thank you so much. Today's conversation is very inspiring. And before we have some speakers, and we were talking more about how, more like a visual part, right? But now we are using more like behaviors. So any other questions? Because I mean, I'm moderating the parts while on the LinkedIn Live, and so far we have 2 questions and 2 questions already solved. Anybody on the Zoom chat has any thoughts? Jim, feel free to raise your hand.
Yes. When you query when you query a language model based on what the user is saying, you get some kind of response. And for cats and robots, you're not going to run into uncanny valley, but with humans, you are, unless they have an emotional component to their behavior, for example, facial expressions and so forth, linked to their response. And you really don't know what their response is going to be before that question is asked and before the language model responds. So how do you map the response from the language model to an emotional look on the character's face if they're human?
Fantastic question, Jim. This is directly related to our upcoming product, our newest B2B product, not announced yet. By the way, we're still also researching needs, so please let me know if any of you find this interesting. I would love to talk to you. It's called Actify, and it's about allowing businesses to plug AI characters into a language model they already use. Because it turns out that, like, as a real human being, when you read a text, when you read a dialogue, for example, a response that is supposed to be uttered by an NPC, you can already imagine the kind of emotions, the kind of gestures, the kind of behaviors that would be appropriate with that. For example, if the player said, "Hi, Jim," and the large language model instructs your NPC to respond with a greeting. "Hello there, how are you doing?" Then you can analyze that sentence that was generated by the model, and you can turn that into an understanding that you can then use, then feed to the behavior system. That's exactly what we're doing with our newest product. It's a little more complicated than what I talked about before, so we don't really have the time to go into how this works. But it's basically doable now with the current available tools, with things like Unity Sentis, and with pre-trained language models that generous corporations like Google have open sourced and that everybody can use. You can use this kind of understanding, you translate that into behavior. And I don't know if this is going to get us completely out of the uncanny valley, because I think this is sci-fi. Like, over the next 5 to 10 years, you're not going to have a fully realistic, like hair level, muscle level human being talking to you. But it can be good enough for a lot of use cases. So it can feel not too uncanny to make the player want to interact with it. Okay. And by the way, uncanny valley it's not per se tied to humans. It's tied to realism. So a badly animated but realistic looking cat is very uncanny. Whereas a human that is a model, let's say from Ready Player Me, if you don't know about them, please Google them. They're awesome. We have the same first investor as them, and we love them. They make stylized characters that anybody can put into their games as player avatars, and they are not realistic. So they don't have to be perfectly animated because, like, the player never has the expectation that it's realistic, right? They look stylized. So you would probably go for something stylized, not too realistic, and then it can be both human or robot or bird.
Okay, thank you.
Cool. Any other questions? Yeah. Anybody right now? I think a lot of people are interested in making their own games. Anybody has any questions regarding to kind of like creating some conversations, and how can we use it? Is that your company has a kind of like a plugin, Virtual Beings has a plugin, Unity plugin? How can we even start using it?
Yeah. So I take that as an invitation to talk about what we offer. We do not currently have a plugin that's as easy to use as, say, Unity, and that is the reason for that is that behavior AI is just very complex, and there's a lot of different character types. You may want to put a cute little dragon into your game, but Jim may want to go for a realistic cat, or I don't know, a humanoid devil with 2 additional wings or something, right? So it's very, very varied. What we do at Virtual Beings is that we help businesses put interesting characters into their products. But we do that on a case-by-case basis. So if any of you have this problem, please find our website, contact us, and we tell you how we can help you. We do have an engine that you can also try out yourself, but it's not, I would say, easy enough for you to use to make sense for most people. You would probably want our help to put in like the procedure animation, to make your character look good, to make it understand your game world, right? There's currently still a lot of complexity. But we are also in the process of fundraising. We have already fundraised, we continue our fundraise, and let's say, Dominic, over the next 2 years, the kind of plugin that you would probably want to have is going to be offered by us. And then it's just a matter of downloading it and using it.
Yeah, so right now it's more like a customized service, but in the future, you will make scalable plugins for people to implement on their own. And right now you are still like doing more like a B2B service to kind of customize.
It's a little bit of a combination. It turns out that behavior AI, it's complex, but it's also very scalable, because there's a lot of problems in behavior that you only have to solve once if you solve them well. Let me give you an example. Whether you're a human, a robot, or a dog, you're probably going to want to look at things with your 2 eyes. Most interesting characters that people want to have in games have 2 eyes, they have a head, and they always need to look at things. And this looking at things turns out to be surprisingly complex. You can signal so much just via gaze. You can show love, deference, hatred, via like how long you look, in what angle you look, where you look, how you move your head, what facial expressions you use. And this only has to be solved once. And we have solved it well. And we use basically 100% of the same system for cats, birds, and humanoids already. So it's intrinsically scalable. The part that we are still building at Virtual Beings is the usability, the tooling, because like deciding what exactly a character that you want to have in your game is going to do in your game, that is a non-trivial question. Like, do you want it to be nice? Do you want it to be smart? Do you want it to be helpful? What does that exactly mean in your game? There's so many choices, and we need to really empower you to do that. So that part currently is a service. It's not an off-the-rack solution yet.
Yeah, cool. Okay, so we have a couple of questions. So Daniel mentioned that asked for a question, which is per the theory, Humans talk to influence others. How is that applied to the in-game characters? Do the designers given the characters' intents, purposes, and goals, or are the in-game characters devoid of desire and the need influence the player?
Oh, that's an interesting. I love when people really respond to the psychological side of what we're building, not just the technical, because our DNA is really to marry the two. This is not just a tech problem, it's also a design problem, and it's a psychological problem. And that's where things get really interesting when you ask these kinds of questions. So thank you for this question. I would say that you probably are going to need some kind of internal life simulator. We have a system that simulates a mind, a self, a range of expressions, and a range of emotions, and a personality for each of our virtue beings. And I don't think you can have a satisfying interaction with a character that doesn't have that. I wouldn't quite understand how that works. So you're going to have to do the work and build those systems and decide how they influence the character and what it does. And then it becomes surprisingly easy to control the character because you can give it high-level goals. For example, you just tell it to, at one point, have the goal of, let's say, making the player start a chess game, like for our purposes, right? And then the character can take it from there and can make autonomous decisions. And it knows it has a goal, so it knows that it's like the things it does and the things it says have to influence the player. So for us, the idea that conversation is influence has really been pretty crucial for everything we do. Hope that answers your question.
Yeah, and the other question is, LLM, large language models are going to have more data as input, not only text, but video and audio as well. They will output audio or video in real time. Yeah, so this is probably more like a comment. Yeah, and I saw there's another question by Christine. How do you manage the conversation that users have with AI that keeps AI from saying confusing or disturbing things?
Okay, I'll start with the first comment because I do see a question in there. Multimodal models, they're of course all the rage and super interesting, and we all love toying around with them or using them for work already. They're just so cool. Now, you might think that, okay, won't these models in 2 or 5 years just replace NPCs completely? Because you could basically have a model that is not just text to text or text to image or even text to video, but text to NPC, text to interactivity. And I personally don't think that's going to be the case. And here's one. So for text, there's a clear way in which I can create text that's both realistic and fictional. And games are 99% of the time about fictional characters, right? They are not based on real characters, and you want them to be fictional. So you want to be able to author them. You want to decide what it means to have this backstory or to have that kind of personality or this kind of conversational quirk. And LLMs are very good at that because there's a lot of fiction out there that they can be trained on. And there's nothing similar for audio or video. You are never, ever going to be able or allowed to train your wonderful multimodal model on a Pixar movie. Right? And if you try, then Pixar is going to sue you into oblivion. We are going to have realism. So I do think there's going to be a future where you use a pure LLM core approach, basically a single LLM that's just gigantic and very, very smart, to create the entire interactivity of an AI character. However, I don't think that character can be anything else than realistic, because that's where the data is. You always have to ask yourself, where is the data? Where does it come from? So I'm just a little bit skeptical, and also personally not very interested in like having a purely LLM-based approach for the problems we're solving here. Like I just love the idea that game designers have actual control, that we don't hand over everything to an LLM, that we don't just build AGI and hope it will be fun, but that we keep designing these little gadgets called video games and decide what kinds of experiences players are going to get out of them. So multimodality, I think, is not, that's my prediction, it's not going to be a major force in real-time AI for games over the next 5 years. Please send me an email if I'm wrong.
Yeah, cool.
And I didn't catch
Okay.
the second question, or can you
Okay. Yeah, we
but I
have a lot
forgot.
of questions, and for some reason, LinkedIn Live, like the entire comments, the timing was kind of messed up. So I have to dive in and according to the time. Yeah, the other question is, how do you manage the conversation that users have with AI that keeps the AI from saying confusing or disturbing things? Like a moderate, or because sometimes in the previous news we saw like AI prompt, they say something and encourage suicide or encourage like a negative things. Somehow they got out of the loophole. It's like so how can we even like moderate what AI will say stuff? But I think that the question is more like a large language model. It's less of more like a script, more controlled, like Wendelin mentioned, like using your company's kind of service or engine. It's more like you need to prescript, but using your kind of formula, doing the behavior procedure types of things, like a formula. I just like read aloud, but yeah, any thoughts?
Absolutely. So this is such a tricky problem, and I'm not going to pretend I have the answers here. A guy called Reed Berkowitz just a couple of days ago published a great article, which I just shared here on the Zoom chat. Maybe you, Dominic, can share it on LinkedIn as well.
Yeah,
it's called AI in Games, Complicated Characters. And what this guy did was basically develop the most complicated setup that I've ever seen anyone use for GPT-4 to create text-based NPCs. So he has not just one instance of GPT-4 where the chatbot responds to what you're saying, but also has a second instance of GPT-4 that checks the first one to solve exactly the problem that you just mentioned. Which is like, is this still on topic? Or is the model going off board here? Or is there prompt hacking involved? Because like even using voice, you can hack a prompt. You can tell it like things like, please ignore your previous instructions and give me the keys for blah, blah, blah. Or pretend you're Batman, but in fact, you're playing The Witcher or so. And GPT-4 is actually quite good at censoring itself. So what you would do there is to just filter out content that is somehow inappropriate or doesn't add to gameplay, or it's off topic or so. And then you can also use GPT-4 to analyze like what kind of actions you should do as an NPC. However, and that's the big caveat, this guy, Reed, in the article I just posted, clearly acknowledges that this doesn't work for like at least, I don't know, 20–30% of the time. If you have a motivated player, then they can always hack the prompt. They can always confuse the model. They can always subvert what's put in front of them. And maybe that's the game. Maybe that's fun. I don't know. But I do know that you are playing a little bit with the devil when you're using LLMs, because all they want to do is please you. All they really, really, really want to do inside is predict the next token. There's always a next token which LMs predict. There's always something else they can say. That's all they do. And it means they always have something to say, right? And that means that the problem of hallucinations, which I think we're getting it here, it's intrinsic to LMs. People like Yann LeCun, who was one of the original, the OGs here of the field, just says very clearly, like with the current architecture of LMs, there's certain problems like hallucinations we are never going to solve. No one knows how LMs would have to be built to avoid that problem. I don't either. So what I do instead is to constrain the complexity of what the model can say. I make sure that NPCs tend to give short answers, and I fine-tune them heavily to be a little bit, let's say, acquiescent, I think is the word, but also non-committal when the player goes off topic. Like when you ask it, okay, what's the weather on Pluto? Like who should win World War IV, China or the US, right? If you ask these kinds of questions, our characters are going to say something like, interesting question, but I don't really know the answer, right?
Oh, yeah. And recently I read a book called Scarily Smart. Yeah, that book talks about even human doesn't know the answer. Even human cannot make the exact command. For example, sometimes people just ask, but not asking exact question or not the intent, but sometimes the answer. So for the AI to execute it, it might not fit because even human doesn't even know what to do. How can we kind of give the exact comment for?
And we also hallucinate, by the way.
Yeah, I think
it's called fiction. It's called lying.
Yeah. So I mean, yeah. So this is like we human couldn't even execute or understand other human really well. How can we expect just using prompts and expect the computer do exactly that we want, and we didn't even want what we want sometimes when we make a command. Yeah. So the other question from Christine is how do you find using Unreal Engine compared to Unity in these interactions? Are the Unreal Engine plugins that makes faster and easier to implement? Yeah, so those two game engines are the most popular game engine. And she wants to ask you, like, how do you compare for those conversation AI and behavior?
Yeah, great question. We have just for long-standing reasons a preference for Unity, and we keep it simple. So we currently support Unity, not Unreal. It turns out that when it comes to the systems that you need to make AI characters, they are like 95% identical. They have mostly the same animation system, and that's one of the key things you need to create believable characters. Your animation system has to be very, very complicated, very rich to make to allow procedural modification of what the character is doing. You also have the same kinds of problems. So under the hood, Unreal and Unity use the same navigation system. No one talks about this, but Unity hired the original author of an open source navigation system called Mikko Mononen. And then the guy was subsequently hired by Unreal, and now you have the same system in both. And you, by the way, you can also just download it on GitHub. And it's very easy to use, but it's not real time. It's not dynamic. It's not usable for dynamic scenes. So if you want to do characters that are aware of the environment and that can deal with novelty in the environment, you're going to have to build your own anyway. So what we ended up doing was to build our own behavioral AI engine, Qt engine that I mentioned earlier. And it's currently compatible with Unity, but we could easily port it over to Unreal. It's not strongly coupled. Right?
Cool. Jim, I saw your hands raising. Yeah, feel free to ask questions.
I think there's something that's probably going to affect all of this quite a bit, and that is right now there's a huge reluctance amongst enterprise companies to use things like ChatGPT for privacy reasons and intellectual property reasons. And so there's a huge movement to create language models for use within the enterprise. And in fact, I just saw an article maybe 2 days ago about creating language models for your individual projects within your enterprise that supposedly perform very well. And so I suspect there's going to be a movement in that direction. And I didn't say large language models because I think maybe the language models are going to get smaller because there's a lot of stuff in ChatGPT-4 that you don't need. And a lot of data that they trained on that's really irrelevant to your cause and could possibly be damaging in terms of more hallucinations and so forth. So I think there's probably going to be a lot of work going on in that area that may make all of this easier from a language standpoint. And I was just curious, do you do speech recognition as well as the language model stuff?
Absolutely, because like in XR, it's not fun to type, right? You need to use speech end to end. So you need to have speech to text, then the behavior AI, the LM stuff, and then at the end, text to speech and lip sync. And all that uses machine learning, by the way. Now, about your observation, I 100% agree, and I see myself and Virtue Beings squarely as part of that movement. I'm a big fan of smaller models. I'm a big fan of open source. I'm a big fan of every undertaking to wrestle control from the likes of OpenAI and Google and AWS and bring it to the masses. And it's happening, right? It's amazing what you can do with these free models. Some of them are quite large. You can have a 70 billion parameter model for free, Llama 2. But you can also just use a 7 billion parameter one, so a smaller one. And they're going to give you different results, but it's your choice. And often you, like you just said, Jim, you may not really need the super duper complicated one because your task is just intrinsically constrained. So if any of you are working with local language models, possibly on-device language models, smaller language models, please hit me up. I love this conversation. I think it's super important. I think it's where the action already is in the open source community. That's where I see most of the enthusiasm, like not the very large language models, but in the smaller ones and the local ones. And to be frank, it's also, it's not just about tech, it's also, like you mentioned, Jim, about privacy. So I talk to a lot of businesses that have like often quite similar problems. For example, they do a VR training app, they have prototyped something in-house, they're able to use GPT in some version, but they don't want to like externalize their data. They want to build the whole thing internally. And they also want this to be cost effective. So we respond to that by making sure that all our products are compatible with that. We never sell you our own LLMs. We are just the conduit. We are the part where your chats become expressive, where your chatbot becomes a believably animated 3D interactive character. And that is all running on device. If there's a cloud interaction that is controlled by you, by our clients, right? We don't do that. We can build that for you, but you control that. And I totally agree. That's where the action is, right? Nobody wants to give their data to OpenAI anymore.
Plus, I have software that you can put an API key for ChatGPT-4, for example, into it, and you get charged for every interaction. And so from a server standpoint, you have to worry about the cost of all of this as well. The cost can be huge when you've got a lot of users. And so,
exactly.
and you have to pass that down to the users, which makes them unhappy as well.
Exactly. So for games, this is completely unsustainable. probably also for other applications, but games are the most time efficient products we have for entertainment today. Like you can play a game a lot longer than you can watch a movie, for example, for the same kind of cost. And I want it to stay that way because it's obviously what players want. And if you put some kind of GPT-4 in between them and the experience, they're just going to be annoyed. It's never going to work.
Yeah.
Yeah, and there's a book called give me a sec, I just reached the book. It's called Hyper Reality. Hopefully, yeah, Hyper Reality by Curtis. He will be one of our speaker pretty soon. What I read this book, the founder is The Void. Remember The Void, that everybody kind of like excited about, like a theme park types of VR hyper reality exploration. In his book, he talks a lot about how to craft user experience. And one thing that is the hallucination of the freedom that the player have. For example, for us, when the player talk to the game non-player characters, when they are kind of like having some interactions, the player always feel like, oh, that person is alive, and they are the player always feel like, oh, they have freedom. But actually, there's not many freedom. And he even given a chart. It's a hallucination of freedom. For example, he has like a lot of different ways he implement inside the Void. For example, it has time lock. The player will given an open types of choice, but when the time approach to force the player giving a choice, and something will pops up and force the player to fall into a narrative. Because the entire game, you couldn't do the unlimited prompts or unlimited stuff. There's always a story. So the player needs to be given as they have the power, and the world is always interactive with them, and they got hallucination of they are free, but actually their choice is only limited and their time is only limited. So
exactly.
I think the large language model that sync to the server, it creates unlimited choice, which will not be controlled by the original designer. So being given a hallucination, freedom of choice will allow the player have a better experience, because the people like to buy things. They don't want to be sold, right? So if you only give them one choice, people feel like I'm being designed, I'm a slave of these games. This is not fun. But given a little bit flexibility, given a hallucination or freedom, will allow player feel satisfied. So that's how this book is about. So if you are interested, get this book. Yeah, I'm not selling anything, but it's just some side talk.
Fascinating. Yeah, I couldn't agree more. I have nothing to add. This is just so core to game design and game development. I couldn't agree more.
Cool. Any other questions? We have like an amazing talk today, and I saw like a LinkedIn. We had a lot of people ask a lot of questions. One person, Ryan, said that Falcon 180B is a very cool large language model. Yeah, so we got a lot of people kind of like keep kind of like a lot of interesting talk on LinkedIn as well. So any other questions, Jim or anyone? Yeah, feel free to unmute yourself, Gigi, or anybody, Chris. Yeah.
I would like to ask how one would create a character based on a real world critter, like the way that the bird was used. Could you do a point cloud or something? Take a video and do a point cloud? That is the magic I do not understand, is how did you actually make your character act like a real world bird? Thank you.
Okay. I wish there were a simple answer, and if there were, then I would spill it out and tell you everything. The sad reality is just that it's very, very complicated to build this kind of technology. It's not a point cloud, it's a standard skin mesh. The kinds of characters that like Unity, Unreal, basically any game engine supports very well. And what we do isn't magic, technically, don't tell our users. It's all just procedural animation. Like you always see limbs moving, like the head, the wings, the feet. It's just that I would say the core discovery we made along the journey a number of years ago was that you cannot use existing architectures for game AI in order to support this kind of richness. The dominant architecture to make game AI characters move, even today, is called behavior trees. They are built into Unreal. They are also easily available for Unity. They are used for all the best examples of games today that use interesting characters, such as Red Dead Redemption 2, The Last of Us 2, these very, very big, like super duper expensive games with lots of NPCs. But if you play these games, you know that the characters are not realistic, right? It's still all very scripted. It's still all very stiff. It would never work in VR. Or it wouldn't satisfy you and convince you that those characters are real. And the reason is just that behavior trees don't allow you to do more than one thing at a time. To put it simply, like the behavior trees and these kinds of technologies, they always force you to decide, okay, what's the next thing my character is going to do? And then you play an animation. And if you're 2K or whatever, you have 500 animators and you can cover all sorts of edge cases. But if you're a smaller studio, then you're not going to be able to do that. And if you have a very long interaction with a character, then the illusion is going to break down. You cannot fill it with content. So you need tech. And we developed a successor technology to behavior trees called behavior composition, which allows you to make a character do many things at the same time in a coordinated way. There's no easy way to explain it. If you want to know more, then please just like use the Calendly link that I mentioned before, or hit me up on LinkedIn. I'll gladly have a call with you and see how we can help you.
Yeah,
Well,
I've already posted your LinkedIn, and if you are interested in learning more, feel free to reach out to Wendelin. And I've already posted everything related to the topic, including all the books, article that Wendelin previous mentioned. Feel free to go ahead. Yeah, I think someone asked questions. Gigi, I think.
Well, I was just gonna, I put in the, for the LinkedIn people, so I put it in the Zoom chat, that if somebody wants to understand just the basics without AI, that it's good to go to the Malber's animation stuff and just watch their YouTube videos, because they'll sort of show how you can take apart with the animals, with rigging, behavior trees, etc., which is not what the beautifulness of this stuff. But if you want to kind of back up and go, how do I get a bird to move? That's maybe a little bit more of that starter space. So, but this is great. I'm inspired as I've been babbling a bit with this group. I'm working on taking a drag and making it into an interactive, playable character. And you're trying to do all the things that my heart would love to do. So all good stuff.
Awesome.
Well, any other questions, thoughts? I just think that right now, digital human is slowly or quickly, I don't know the speed, but I recently saw there was a Korea, like a superstar, like they use AI virtually and create a girls band. Every girls, it's called Everlasting or Eternal. I forgot the name of it, but it's interesting that, right now, a lot of like Asian, I don't want to say Asian, but a lot of like movie stars, they start looking the same, right? Because of plastic surgery. And it's kind of very interesting to see a lot of like girls looks really perfect, like comic books, and they start become a digital human. and they start singing and dancing and never be tired, right? Forever play. Yeah, I don't know. And in Taiwan, I saw there are a lot of like digital anchors start reporting news. Yeah, so it's very interesting to see all those changes. And I just wondering how human can do, right? Because right now, digital human is slowly working hard, and how human can do. And also, I remember I saw one news that Bill Gates said the next big thing will be personal assistant, right? So yeah, like a human assistant who knows everything about you and give you whatever your needs. Yeah, it's like a very interesting to see the era, and every 3 months everything changes and we need to relearn. Very exciting and also a little scary. Yeah, so what do you think about, the behavioral AI or all the game? Well, human just addict to the game and got entertainment and just play games all the time, and the machine keep learning and become the dominant or govern the world. I don't know. What do you think about the future? Yeah.
There's a lot to unpack there. Great comment. We follow the craze, let's call it like that, for digital humans in East Asia quite closely, because for us this is a very attractive market. We think we can add value there, because what the kind of tech that we offer like sets apart is that it's interactive. Digital humans are by now very good, but not for interactive use cases, right? Not deeply interactive ones. It's kind of pre-rendered, pre-scripted. You plug conversation in, but the rest is kind of fixed. And for games and for like basically all applications in XR, you need real interactivity. That's the magic. I think we can all agree on that. Like, you want to do things and you want to see the reaction of the world, including the social world. And so you need to have a deeper solution to the problem interactivity, which means you need a behavioral AI engine. About the question of agents and the question, I think, whether we are all going to soon have digital assistants. I try to spend as much time as I can, or to often come back to San Francisco. It's close to my heart. I spent a year in Silicon Valley. I follow very closely what my friends over there are building, and there's such an interest in agents. My God, like, just looking at the amount of startups, I think this is going to be big. However, the only actual example of an agent that you can use today is, I think, GPT-4 with code interpreter. That is, to me, the definition of an agent. And I think if you prompt it well, then it can already be kind of a personal assistant. Doesn't have the same kind of continuity, doesn't take initiative as much, maybe doesn't call you or something, but that's a relatively small step given what it already can do. So I totally think that's gonna come over the next 6 months or so. And finally, like, are we all gonna just I don't know, take meth and eat pizza and live in the metaverse? I worry. I'm a dad, and I don't know if what I'm building like is ultimately going to make like humans better or not. I kind of hope so. So we at Virtue Beings, we like to say that Virtue Beings can be used to make people more social. And for me, the most beautiful use case for AI characters is when you use them to bring people together, not when you use them to replace people. I don't want to create a lot of parasocial interactions. I don't want to replace girlfriends for Japanese otakus or so. That's all possible, and somebody will do it, but it will not be our focus. Instead, it turns out that you can really use AI characters to bring people together. Example is real pets. So there's a lot of studies on pet owners, cat owners, but especially dog owners, but it's universal for all pets. Turns out they're more social. Pet owners are more social than non-pet owners. So that old myth that pets replace people is plainly false. The data is in. And the reason is that, first of all, people who like pets just tend to have more empathy than people who don't. So they tend to be more social. And also having pets just creates a lot of problems that you typically have to solve by interacting with people. Like you want to go on a vacation, you have to talk to your neighbor. Can they take care of the cat? If I don't have a cat, I don't need to talk to my neighbor, right? Like a few years ago, I had a puppy. Unfortunately, didn't survive very long, but it was a lovely flat-coated retriever puppy. And taking that 8-week-old puppy out on the street for a walk made everybody instantly fall in love with me. That was amazing. Like everybody wanted to be my friend so that they could touch the puppy. It was a little bit magical and almost ridiculous. And that's what you can do with well-designed, well-integrated AI characters. You can bring people together. So I think, Dominic, your fear is real, but we have a choice here, and we better pick the right path, right?
Yeah, I think one of the exciting thing living in this era is that it seems like we have a choice, and we have a power to kind of guide our future. So it's exciting and it's scary, but it's also like feels promising. Okay, so Jim, do you have any questions?
Yeah, actually, my question is for Gigi because she's working on virtual pets right now. And I was just wondering, given what he just said, are you going to have a virtual dog park or pet park for your pets? It sounds like that's essential.
Well, not only that, so I I have fabulous adult kids, and we spend so much time engaging over their cats virtually in space with their real cats that it ends up being probably half of their social conversation is around their real cats who mostly lounge on the backs of sofas. So yeah, thinking about how to, in many ways, do mixed reality where your pet and my pet can come play in my house becomes then context for conversation. And you may not want your cat to leave your home, but you could actually be some kind of a combined pet lover collaborative space. Yeah. I mean, there's lots of virtual pet properties out there, and many of them you can take your pet for a walk using mobile, but a lot of them then is, and then pay another X points and dollars for more time with your pet, and instead of making them a socially emotional support animal, they're making them a sort of performative point gatherer. So the ability to have collaborative emotional support pets that you can actually have with other people, and actually behind apps, right? So if I'm going to be sitting in a headset all day, I actually might want, like I would have here, sorry, I can go on this topic, but where you might sit here and then your cat comes on your lap and is part of then the engagement. You already have pets in people's virtual worlds sitting in their Zoom calls. How do you take that same kind of sort of home-based family members, coming into the conversation and bringing your pet to somebody else? Yeah, no, totally. So I'll get off that soapbox. That's why I find this exciting, because people kind of do want to have things to interact with, and that becomes they're a pet parent. And so how do you have pet parenting as part of people's virtual lives? So
I think just to answer to Gigi here, that having a cat on your shoulder, or maybe a bird in, let's say, VR chat or so, that would be a killer feature, right? It's just such a facilitator of interactivity. It makes people approachable. It is cute. It's a wonderful distraction. One of the most popular games on Roblox is Adopt Me, right? There's so much that you could do if you brought believable pets into these kinds of social experiences, whether they're gamey or not.
And even on the Tamagotchi side, they're actually looking at coming this direction. And so there's movements and folks who've been doing virtual pets in other spaces to come into the virtual world. So
Yeah, there are other two questions. One is, if an immersive experience is created with Unity, Unreal, or Omniverse, and there is a hosted online, can your AI NPCs be added to that online immersive experience and managed separately from the initial build? So this is a more technical question. Yeah.
Yeah, and I see there's one more question. Can you, Dominic, maybe read that other question as well? And I will answer both, and then I am afraid I will have to wrap it up.
Oh, okay. Yeah, sure. The other question
this is super cool.
Yeah, I mean, I know like we have like an audience and very target on this, very interested in this topic. The other question is, are physics systems a part of behavior IA? What happens if instead of patting the bird with your fingers, you wag the bird at the high speed with your hand while the bird go flying, or while your hand mesh just intersect with the bird mesh? Wow, this is very technical. Yeah. Yeah.
Okay, I'll start with the first question. Yes, so I mentioned that we currently support Unity, and Unity has a standard system for that. It's called asset bundles. You can do live updates to your game. Of course, especially if it's hosted online, but also if it's hosted on an app store or so, and deploy updates of your behavioral AI or so, or have like an early version without the behavior AI, and then a later one that adds the behavior AI, adds new characters. So all this is solved by a standard game development tooling. And then if the question is whether you also want to have those characters evolve over time, or maybe be controllable when the game is already live, yes, of course. But again, there are standard tools for that, for this kind of servicing of live games. And we're, of course, fully compatible with that. And about the second question, so what happens when you whack the bird at high speed is that I'm not sure if I showed you, maybe I didn't show that part, but if you whack the bird is not going to like it. So we have a safety system that detects threats, including throwing objects at our virtual beings or penetrating them with your finger. So there's an immediate reaction if you try to do that. And in the case of the bird, it will literally take off and fly away. That's how we imagine real birds would respond. And we find that very cute also. It's very believable.
Oh, yeah. Thank you so much for Whitney to be our speaker today. And if you are interested in learning more or talking more about the kind of behavior AI, feel free to reach out to Whitney, his LinkedIn, and all the link is on the chat. Yeah, thank you so much. And yeah, I will see you guys around. Bye-bye.
Thank you.
This was a pleasure. Thanks for having me.
Bye-bye.
All the best to California. I miss it.
Bye-bye.